All right, in the following video, we're going to try to figure out the recoil speed of an electron. In the last video, we did all this work and we found out a bunch of information, but we had basically a photon coming in to hit an electron at rest. The initial wavelength of the photon was 0.1769 picometers, pico being 10 to the minus 12th. So, right, a tiny amount of nanometers, like a 10,000th of a nanometer almost. Okay, and then the photon hits the electron at rest. It loses some energy, so it goes to a longer wavelength. Sloppy. It recoiled at some angle 37. This was measured in the lab by some student that's unfortunately having to do this work. And then the electron goes flying off and at some angle. And in the last video, I believe we found this angle ended up being, we did a conservation momentum problem, took the ratio, and we found this angle was something like 11, well, I've got it right here. Let's just scoot over. We found all this information. Whoops. All right, so that was the problem we did in the last video. And now my question is, how can I determine the final speed of the electron? To give you a visual here, let's go to the simulation again, just in case, right? We're looking at the photon comes in, the electron gets scattered down. We've figured out this angle is 11, whatever, it's 11.48, which matches right there. And we knew this angle was 37 degrees. That, all right, that was what our given was. We knew the initial wavelength. We found the final wavelength, so we know both lambda naught right here and lambda prime right up here. We know both wavelengths. We know basically, we know theta, we know everything except for the speed of this electron. The computer claims it's this, and my goal is to have you derive that. All right, so let's finish with the screen share there. Stop share. All right, and now if you want to pause the video and attack it, great. I'm going to move on in 3, 2, 1. Whoops. I'm going to go this way. There's a couple of styles you could approach here. The first one is we determined phi already. Couldn't we just use this equation right here? We know what this momentum is. That momenta is h over lambda prime. We know lambda prime from the previous result. We know theta is 37 degrees. All those numbers were on that first screen. If not, rewind the video and you can see it. From that, I can get the momentum of the electron. This is the tricky part. This gamma is the Lorentz factor gamma, not the photon gamma. All right? This gamma means photon. This gamma means Lorentz factor. So in this problem, this has u in it. Remember, when we're doing relativistic speeds, we oftentimes use u instead of v for the speed. All right, but we've got this number. Style 2, maybe you remember this from physics 1. This is actually the way I did it because I solved for the speed first, but I think that was solved for the angle first is easier. I'm just going to square these, every single term. You probably remember this from physics 1. When I square these and add them, this is in physics 110, it was in physics 1. I'm hoping you remember this. The key thing to see is that on this side, we're going to get PE squared sine squared plus PE squared cosine squared. This is basically PE squared equals a bunch of numbers. We can get PE the same way. And this is actually, you basically derive the law of cosines when you're doing that if you're curious. You could do that with Pythagorean theorem. All right, so now that we know the momentum, it basically, momenta of the electron, it basically reduces to this problem. PE, which is a known number, this is the rest mass, which we know. So we know this number, we know this number, and gamma is this thing which has the speed in it. So the whole problem is essentially solve that for you. I'm going to pause here. 3, 2, 1. Here comes the answer. Last chance to pause the video. Over. All right, and so I'm going to divide by that rest mass, get all our knowns over here. And I'm gonna not write rest, okay? I'm just gonna write M, and you're supposed to know that this is the rest mass because I don't wanna write rest a billion times, okay? So this is equal to gamma U. And now we could do a bunch of different things. I see that there's a square root in there. Maybe I'll actually write this out, U over the square root of 1 minus U squared over C squared. I'm gonna square both sides. At this point, the problem should be easy, right? It's just solving for U. And you can see that I've got a U squared here, a U squared there, cross multiply, group like terms, you should be there. Ratio, go. All right, maybe I'll multiply, let's just keep going here. A lot of these relativistic calculations end up looking kind of like this. Oops. I don't want to screw this up. But notice I could bring this inside if I take off the squared. I'm going to show you that again. So U squared over C squared, this term is squared. I could bring the C inside and get rid of that. Notice I still have an over C squared. Well, now it's a little bit easier for me to work on. Let's see, this is going to be plus. I'm going to get out of the way just to make sure you can see that. Oh, I forgot a C. That's tricky. Making sure I didn't screw up anything else. Okay? And then from here, take a square root. Now, in this case, remember that M was 9.11 times 10 to the negative 31 kilograms. That's the rest mass of an electron. PE, depending on which style you used, either one, we found it was something like 3.0105 times 10 to the minus 21 kilogram meter per second. Just look at this. If you divide PE by the mass, we're going to get something that's like 10 to the 10 meters per second. That's bigger than the speed of light. Maybe it's 10 to the 9th, something like that. But so, yeah, this clearly requires relativity, right? And I'll do a quick note on the units. Think about this. Momentum from physics 1, you probably remember physics 1, P is equal to mv if it's non-relativistic. All right. And notice, just as a unit check, This thing right here had better have units of speed squared. This term here has no units. So when you take the square root, we'll get units of speed. This works out. And what did I get? I got, when you plug in these numbers, I found u is equal to 2.9857. Let's round this in the third digit. Aha, 2.99 meters per second. If you did beta, right, you could get beta, and I found 0.9959. So I found beta was 0.9959, I think. Yeah. All right, so that's a trickier problem. You can see that takes a little bit of algebra there. Not too bad, though.